radical expressions, how they're used in logarithmic expressions, and how we find the answer for those logarithms. So let's do a little review of radical expressions and changing those to the rational exponents, because the goal is to find an expression that does have an exponent, because those are really important in logarithms, and oftentimes logarithms are equal to the exponents. All the time logarithms are equal to the exponents. So changing this to an exponent form becomes really important. So what I want to look at is this first example. A couple things to learn terminology wise. This we should already know. We've got a base of x, an exponent of 2, but many people don't necessarily know the word for this little number here, and that word is called the index. So that whatever number is there is called the index. Just a quick note, if this was just a square root, there's not normally a number there, but there is one that's understood. So if it's a square root, there is an understood index of 2. And that may come to play later, so make sure you remember that. Also, if there's no exponent there, it is understood to be 1. Okay, so now let's talk about how we convert a radical expression to an expression with a rational, as in fractional, exponent. So we're going to keep the same base. The exponent here, the 2 in this case, will go to the numerator, and the index, the 3 in this case, will go to the denominator. And this 2/3 is up in the exponent of this expression. So, I mean, if I wrote this by hand, I would normally write it this way. I might not write it so up and down, but that's okay. Either way is fine. So one more time, exponent on the top, index on the bottom. So let's figure out what we have here with 7a. Again, we're just rewriting this radical expression to be an expression with a rational exponent. So our base is 3. Our exponent here is 5, so we're going to write that first. And then what is our index? So this does not have a little number right here. Remember that this is going to be similar to this. So it's a square root, so our index here is just a 2. So this ends up being 3 to the 5 halves. And that 5 halves is your exponent. Let's look at B. Our exponent here is a 1, because there's not 1, so it's understood to be 1. Our base is x. The exponent on that base, 1, will be in the numerator. And the index, 4, is going to be in the denominator of the exponent. So what will this be? This is going to be 9 to the 1, understood, over 5. And this one I've already done. I just did it right there. So this is going to be, let's convert it, x to the 1 that's understood over 2 that's understood. So x to the 1/2. So now that we practiced just converting a radical to a rational exponent, let's talk about how this relates to logarithms. So what I first want to do is change this radical, and this will happen every time that you see a logarithm. I want you to change that radical to a rational exponent. So this is going to be log base 3, so that part stays the same. But this square root of 3 to the 5th is going to change to 3 to the 5 halves. And we actually just did it right there. Now, use the rule that you've learned before. If the base to the logarithm and the base to the exponential expression are the same, the answer is the exponent on the exponential expression. So here, the bases are the same. My answer is just 5 halves. So I literally just write 5 halves. Let's look at 8b. Here I have log base x. I want to convert this to x to some power. So here I've got x to the 1/4. Again, just did it right there. Bases are the same. Exponent is the answer. So this is really combining the rule that we learned earlier and this rule with the radicals here. All right, log base 9. Convert this to 9 to the 1/5. Bases are the same. Answer is 1/5. And this one, log base x of x to the 1/2. Answer is 1/2. Okay, now I will say this. If you can understand that these bases are the same and that this converts to 5/2 and that the exponent is your answer, you could just skip straight down to the answer, 5/2. That's totally fine. We want you to be able, there's not a lot of things that we say, take the shortcut. We usually say, we want to see your work. And showing the work is good. And if that helps you see this, certainly you should show your work. But if you are understanding this concept that the bases are the same and how to convert that radical to an exponential, radical to a rational exponent, then certainly you could just go straight to the exponent and be done.